So there's a visitor in our solar system. It's come from that deep, dark void between the stars. And honestly, with every new thing we learn about it, it just defies everything we thought we knew. It's a total puzzle, a real enigma, and it presents a chilling logical chain of anomalies that, well, they just don't add up. Okay, let's dive right into this cosmic detective story. So, what in the world are we looking at here? Is it just another comet, a wandering piece of ice and rock, or is it something more? That's really the central question we're tackling, and the evidence we're about to walk through is, well, it's pretty mind-bending. To try and make sense of it all, we're going to follow the framework laid out by Professor Avi Loeb from Harvard University. He's done something pretty bold. He's systematically categorized all the weird things about this object, which he calls 3I/Atlas. He's broken them down into 3 groups: large, medium, and small anomalies. And when you see them all laid out like that, the pattern that starts to emerge is, well, it's both fascinating and, frankly, deeply unsettling. We're going to start with what Professor Loeb calls the large anomalies. These are the big ones, right? The clues that are so strange, so out there that there's just no simple, natural explanation for them. Think of these as the absolute smoking guns in our little investigation. Okay, so the first clue is its orbit. The path 3I/Atlas is taking is a near-perfect match to Jupiter's Hill radius. That's a very specific zone of gravitational influence. The precision is just astonishing. It's like something out of a textbook survey model, not a random object tumbling through space. But here's the really bizarre part. It performed a tiny course correction, a little microgravity thrust, at the exact moment it was eclipsed by the sun, completely hidden from our view. I mean, that is the perfect time to make an adjustment if you didn't want to be seen, right? And what's really fascinating is how this connects to the legendary astronomer Carl Sagan. Way back in the 1960s, his team actually modeled the ideal place you'd want to park a long-term interstellar probe to observe our solar system. And where was that spot? You guessed it, the exact location where 3I/Atlas has decided to hang out. Is that just a wild coincidence, or is that a deliberate strategy? And its path, it wasn't just some random flyby. No, it took what independent simulations are showing to be a near-optimal route for observing 3 planets in the shortest amount of time possible. It really looks less like a wandering comet and more like a deliberate interplanetary reconnaissance mission. Then there's the size of this thing. We've seen a couple of other interstellar visitors, sure, but 3I/Atlas is in a whole other league. It's nearly 1,000,000 times larger than Oumuamua was. Statistically, an object this massive should only show up in our little cosmic neighborhood maybe once every few million years. Yet, here it is, the 3rd one we've seen in less than a decade. The numbers just don't make sense. Next up, let's talk about its so-called jets. On a normal comet, you'd expect to see these messy, turbulent jets of gas and dust spraying out from melting ice. But 3I/Atlas, it was seen with this, a clean, forward-facing streak of light, almost like a searchlight. It actually bears a striking resemblance to some theoretical designs for particle shields on advanced spacecraft, the kind designed to sweep away dust at incredibly high speeds. Now for what it's made of. Analysis shows an unusually high nickel content, which is unlike any of the thousands of comets we've ever studied. It looks less like a primordial piece of space rock and a lot more like an industrial nickel alloy. And even stranger, it just so happens to match theoretical models for what a 22nd century spacecraft hull might be made of, designed specifically to survive those long, brutal journeys through interstellar space. And the last of the large anomalies is this. It's in what we call a retrograde orbit. It's going against the flow of traffic in the solar system. Yet, it stays perfectly aligned with the ecliptic plane, which is basically the highway all the planets travel on. The probability of an object naturally falling into such a precise, stable, backwards orbit is almost 0. It seems like it would need constant adjustments to stay on that path. Okay, that was all the heavy stuff. Now we're moving into Professor Loeb's second category, the medium anomalies. These are clues that, could, maybe, be statistical flukes on their own, but when you look at them in the context of everything else, they become these eerie echoes, these disturbing coincidences that add a whole new, chilling layer to this mystery. And this one might be the most chilling of all. Back in 1977, astronomers detected the WOW signal. It's the most famous, powerful, and mysterious potential alien radio signal in history. It came from the direction of the Sagittarius constellation, and it was never heard from again. Decades later, 3i/Atlas arrives from the exact same region of the sky. So what are the odds of that? Well, the probability of these two completely unique, totally unexplained phenomena, the most famous potential alien signal, and the absolute strangest interstellar object ever seen originating from the same patch of sky just by chance, is a tiny 0.6%. It's the kind of coincidence that makes even the most hardcore skeptics just stop and think for a second. The other medium anomaly is how it reflects light. It shows this extremely rare signature called deep negative polarization. It's something we've seen in less than 1% of all comets, and it suggests that its surface isn't just a chaotic jumble of ice and dust. Instead, some models suggest it's more consistent with something like a metallic reflective surface, or some other kind of ordered structure. All right, finally, let's look at the third category, the small anomalies. Now, individually, any one of these, you could probably dismiss it as just a weird quirk. But when you see them all together, on the very same object, it becomes a case of death by 1,000 cuts. The combined weight of the evidence is it's overwhelming. Let's just run through the list real quick. First, it has extremely low water content, so it's not your typical dirty snowball comet. Second, as it got closer to the sun, it turned this intense blue color, a color we associate with high-energy plasma, while normal comets turn red. Its jets were also way too powerful for its size, suggesting some kind of propulsion. And those jets, they stayed perfectly stable even as the object rotated every 16 hours, which implies active control. And finally, it sped up without breaking apart, a huge sign of a controlled engine, not natural forces. So, we've got the large, the medium, and the small anomalies. We've looked at all the clues. Now it's time to put it all together. This is where our cosmic detective story really reaches its climax. What is the statistical verdict here? We're faced with a choice. Is this just a very, very, very weird natural comet? Or have we crossed a line into statistical impossibility? What are the actual chances of a single natural object having all of these characteristics at the same time? When you multiply the probabilities of each of these independent, incredibly rare events all happening together, you get a number that is it's almost absurd. The probability of this all being one giant coincidence is less than 1 in a trillion. Just let that sink in for a second. This isn't just rare. For statisticians and physicists, a number that small is effectively zero. It's so improbable that it stops having any real physical meaning. We are no longer in the realm of luck, we are firmly in the realm of the impossible. And this is the crucial point, right from the expert whose framework we've been using this whole time. As Professor Loeb himself says, this isn't just a string of bad luck for our models. The sheer number of coincidences goes way beyond what natural statistics can reasonably explain. But here's where science pulls us back from the edge. Despite these staggering odds, Loeb doesn't just jump to conclusions. His official stance is clear. We have to wait for more definitive data. He believes that precise spectroscopic measurements of the object's jets could be the key, the thing that could finally distinguish between natural ice and something far more advanced. And so that leaves us with the ultimate question. Are we witnessing a 1 in a trillion natural marvel? A comet so bizarre it's going to rewrite all of our textbooks? Or have we stumbled upon something else entirely? A clue, a signal, maybe even a message that humanity is only just now becoming mature enough to recognize? The exploration has just begun.